This garage is in really bad shape. The plan is to tear it down and put something better in its place. The problem is it's got stuff inside, stuff that needs to go somewhere. To solve that, I was planning to build this shed, here. That is until I started watching this guy on YouTube. He does a style of building called post-framing. Post-framing is cool for a few reasons. First of all, it's a relatively simple and fast framing method, and it's just easy to understand in a way, for me at least, that stick framing is kind of not. For example, you can get the main structure up, and then you can install doors or windows pretty much anywhere you want after the fact, because those big burly posts are doing all of the load bearing for you. Second of all, it seems to use a little bit less lumber overall than stick framing, and last but not least, you can get a roof on it super quickly and then kind of finish all of the underpinnings afterwards, which is important if you live in an area that has a lot of rain like we do. My existing shed model uses stick framing, also called platform framing design, which honestly for a shed and most residential buildings for that matter is totally fine. But this shed's purpose is twofold. Fold number one, be a dry place to store the aforementioned stuff, and fold number two, be a practice round for the structure that will eventually replace the garage. That is why I want to try and use post framing to build this shed. So you guessed it, back into SketchUp to model it up. This probably took me about 5 hours total over the course of 3 or 4 days, but in the end I had my complete shed model and of course an updated materials list. Very well worth it in my opinion. The first step, of course, was to gather some official layout rocks and position the shed roughly where I wanted it to be in the backyard. The total dimensions here are going to be 8 by 16. That's 4 sheets of 4 by 8 plywood laid next to each other. Next, I grabbed my trusty batter boards from the garden bed project, but this time instead of wooden stakes, I used these much burlier nail stakes to anchor them in place. These things held the batter boards nice and firmly this time when I started pulling my string lines. Speaking of string lines, once the batter boards were all secured, I got some dimensions from my model and used string to lay out the post locations around the perimeter. After the layout was done, I could get to the fun part, which is digging some post holes. We don't get too far below zero here for very long in the winter, so I don't think I have to worry too much about frost heave. So I aimed for about 36 inches deep, and I'm digging post holes for 12-inch diameter form tubes. I aimed for a few inches above grade here with these tubes, just so the bottoms of the posts don't get wet when it rains. And once they were all marked out, I cut them with a reciprocating saw, and I was good to go on the forms. It ended up taking 22 bags of 80-pound concrete mix in total to fill these things up, and to do that I got one of these mud mixers from the local rental shop. Now, I'm probably late to the party on this, honestly, but man, this thing is amazing. This is by far the easiest concrete pour I've ever done. Not that I've done that many, but this thing's great. You just dump a bag of concrete in the top, hook it up to a garden hose, hook it up to power, and then just turn it on. It injects water into the dry mix right in front of an auger and then just sort of poops out concrete on the business end. Honestly, I cannot recommend this thing highly enough. It's totally operatable by one person, and I don't think I'll ever pour concrete another way if I can possibly help it. After each tube was full, I troweled off the top for a somewhat nice finish, and then inserted the post brackets. These post brackets are probably super overkill for this, honestly. They're from a company called Midwest Permacolumn, and I think these totaled about $600+ including shipping for 6 brackets at the end of the day. Total overkill, but honestly they're super nice and I'm sure they'll last forever. The next step was to start making up my posts. These are 3 layers of 2x6 all sandwiched together, and to make them I made a story pole, one for the short columns in the back on the low side of the roof and one for the tall columns in the front on the high side of the roof. These have an angle at the top for the angle of the roof, and marks for each of the girts. The girts are the horizontal pieces that span in between each post. I also, of course, marked the nominal bottom of each column. This is sort of relative because each of the brackets is at a different elevation, so for the low brackets, I would add a little bit to make up for the elevation difference. I cut an angle at the top of each piece to accommodate my 212 roof pitch, and then started laminating the columns together using screws and lots of nails. Okay, here's a little bit better explanation of how I found the elevation difference between the post brackets. First, I took a long straight 2x6, this one will act as one of my fascia boards later, and I went to the bracket that was pretty obviously the highest one. That's the one you see here on the right. I then set the 2x6 even with one of the bolt holes only on the high bracket. Then I leveled the 2x6 all the way across the front and measured the height difference between the bottom of the 2x6 and that common bolt hole point. That gave me an elevation difference for each of the brackets, and then I repeated this process on the back and found the relative elevation difference between the front row and the back row. That gave me the amount that I needed to add to each low post to make up for the height difference between it and the highest post. Hopefully that makes sense. I'm sure this could be done a lot better with a laser, but I don't have a laser and it was a little bit too expensive to buy just for this project. I numbered each post to make sure I could keep track of where they were going, and then added this makeup dimension to the bottom of each. After that, I could cut them to length in 2 passes because they were too thick for my miter saw. And then for a little bit of added protection, I brushed on a nice thick coat of this wood preservative to the bottom of each post. These posts won't technically be in contact with the ground, but they will be close, so I like the idea of having this on here to prevent rot just in case. I got a helping hand from Anne here to plumb up the posts as I stood them up, and then use these temporary lag screws to tack them in place before coming back and drilling larger holes for more permanent through bolts. Installing the rim joists was pretty easy given that I already had marks from my story pole earlier, but I used a level just to make sure everything was still good to go. I used some ratcheting tie-down straps to plumb up the outside posts before installing girts, since everything is still pretty movable at this point. And I got some help from Anne, holding girts in place while I nailed them up. And the rest of the girts went up pretty quickly at this point. Just plumb things up with tie downs, nail in some girts, and rinse and repeat. I'm just using some regular 2x8s for the roof beams here. They're super easy to install given that the correct angles are already cut into the post tops, and there's even a little groove for them to slot right into. Pretty cool. Okay, quick pause here to point out kind of a dumb mistake. So I took the time to plumb up all of the corner posts with those tie downs like you saw me doing earlier, but somehow I missed these 2 middle posts. And in this shot, they're actually leaning a little bit far apart from each other. They're not perfectly plumb. And I locked them into that position by installing this roof beam. That's going to create some problems down the road later, but we'll get there. I nailed everything together and then just chopped off the remainders with a reciprocating saw. These little ears, for lack of a better term, are the thing that took me the longest to figure out about the post frame roofing system, but they're pretty cool. They hold up the fascia boards, and they also seem to lock the roof into the rest of the structure by being attached at the top of the posts. That's what the last little bit of slot here at the top of the post is for. After these guys are installed, it's time for purlins. These are the pieces that span the roof beams and support the rest of the roof structure. To attach them, I'm using these massive 6-inch nails, and honestly, I had a pretty hard time pounding these in. I am not the most accomplished hammer user quite yet, which might be kind of a weird thing to say, but honestly, it's pretty difficult to pound these in quickly without bending one and messing the whole thing up. We ended up getting some pretty heavy rain during the build process here, so I had to get this giant tarp to cover everything up and keep it relatively dry. In the spirit of pointing out my own mistakes, I should have taken way more time and been way more careful with my purlin spacing layout here. This, in combination with the mistake I pointed out earlier with the non-plumb middle posts, made installing roof sheathing kind of a pain in the butt later. I also mispositioned these back two purlins just a little bit and had to chop some off, but that was an easy mistake to fix. After the purlins, it was fascia time. I screwed in a couple of little temporary blocks here that I could clamp to, which actually made this a pretty easy one-person job. I used some 3.5-inch screws to secure the fascia boards into the end of the purlins. I got a little annoyed climbing into the tree branches here and getting spider webs all over me, so I took a brief tree trimming break. Okay, back to work. Okay, here's where you can really see the results of that mistake I was talking about earlier. That middle ear is sticking out way too far. To fix this, I pulled a line between the two endpoints, marked the middle ear, and then chopped off a little bit to make sure the fascia board would actually be straight when I installed it later. Speaking of fascia boards, the front and back were a little bit too long to do by myself, so I got some help from Anne. The next step was to cut and install some perpendicular blocking along the front and the back that will support the soffit later on. I was very happy to finally get to roof sheathing, and I ended up losing some footage here, but you can use your imagination. After that was done, I rolled out some roofing felt and tacked it down, and then I decided to pause on the roofing for just a second and give the fascia boards at least one coat of paint. I'm going to be installing some roof flashing later, but if any water does happen to make its way in, I'd like the boards to at least have a little bit of paint on them so they stand a chance of not absorbing that moisture. And with that, it's finally time to finish off this roof. I'm using standard galvanized steel corrugated panels here, which come in 12-foot lengths, which is pretty nice because I can span the entire width of my roof from top to bottom. To start off with, I laid down a bead of roofing sealant to tack the closure strips in place, then laid down my panels and tacked those in place with some roofing screws. This ended up being a pretty simple process, just rinse and repeat, since I thankfully made sure that my roof was actually square by checking the diagonals before I started. I made sure to drill through the ridges on these panels since that's what the manufacturer recommended, and I snapped some chalk lines to make sure everything would be neat and tidy. The final step was just to trim off the little bit of excess with an angle grinder, and that was it for this roof. It can rain all it wants, and I don't care. And that is where I will leave you for this video. If you want to see the next video, maybe subscribe. And if you like this video, maybe give it a like. Alright, see you next time.